Hello everyone, my name is Emerald Omva, and today I'll be presenting my PostgreSQL database setup on a Linux server. PostgreSQL is a powerful open source relational database system that's known for its reliability, flexibility, and strong community support. In this project, I configured PostgreSQL to listen on its default port, verified that configuration using an Nmap scan from Kali Linux machine, and then applied 3 key hardening steps to make the database more secure. On this slide, we'll talk about just database overall. PostgreSQL communicates over TCP port 5432, which is its default port for database connections. To make sure my server was properly configured, I first edited the PostgreSQL.conf file to set listen underscore addresses to 0.0.0.0, allowing network access. Then I updated pg underscore hba dot conf, which controls client authentication, to permit connections from my Kali machine's IP. After restarting PostgreSQL, I verified it was listening with the command ss-tlnp grep5432. Finally, my Kali system, I ran an Nmap scan using Nmap -s capital T -p5432 -pn brackets the server IP address bracket and another set of brackets. The results showed 5432 -TCP open PostgreSQL, confirming that the databases was active and reachable, a sign that the connection configuration was successful. On to hardening. For hardening recommendations, I would first start off with strict listening and restrict listening and access. PostgreSQL was running. My first hardening step focused on limiting who could access the database. Instead of leaving it open to all IPs, I restricted the listen underscore addresses settings to only the specific server and trusted client IPs. In the pg underscore hba .conf file, I configured it so only known users from certain subnets could connect, and I enforced MD5 or scram-SHA-256 authentication instead of trust. This follows the principles of least privileged. Only approved hosts and users can access the PostgreSQL database. It's like locking doors to your data center. Only people with the key can get in. The second hardening recommendation is to have strong authentication and encryption. The second hardening recommendation focuses on securing the authentication and data transmission process. I enabled scram-SHA-256 password encryption by editing the configuration line password underscore encryption, which would equal scram-sha-256. Then I enabled SSL in the PostgreSQL by setting SSL equals on using valid server certificates. This ensures all data between the database and client is encrypted, protecting usernames, passwords, and queries from being captured on the network. Strong encryption and authentication help prevent credential theft and man-in-the-middle attacks, which are common risks in database environments. The third hardening recommendation is OS level protection and maintenance. The final hardening step focuses on protecting the server environment that PostgreSQL runs on. I used the UFW firewall to restrict port 5432 so that only my Kali test machine could connect during the scan. I also made PostgreSQL run under its dedicated Linux user account and not under the root, following best security practice. And lastly, I kept both the OS and PostgreSQL packages updated using sudo apt update and sudo apt upgrade -y. These simple steps reduce exposure, minimize privilege, escalation risk, and keep the database server stable and secure. On this slide, I have some references and a memory trick just to help with my closing. Um, The references here are the ones that supported my configuration and security choices, including PostgreSQL's official documentation, Enterprise's DB's hardening guide, Persona's best practices, and the CIS benchmark. My memory trick for this setup is LAP. This basically means listen, authenticate, and patch. It's an easy way to remember. You should always know where your database listens, verify who's allowed to connect, and keep everything patched up to date. In short, this project showed how to configure PostgreSQL, confirm its default port visible within MAP, and apply 3 layers of hardening protect both database and the host system.